All right, we are looking at complex numbers this time, and we'll go ahead and start with this one here. When we're doing these, the one thing you need to know is that I squared is equal to -1. So we want to figure out how many I squareds are really in here. You can do that by just saying 55 divided by 2, which says there's 27 whole ones in there, which would make it 54. But then we have one leftover I. So again, this would give us our 54, and then this would give us our one leftover one. The reason that that is important is that this now is -1 to the 27th power. So it's an odd power, so that would make that a -1. You could also plug it into your calculator and verify that that's equal to -1. If you did plug it into your calculator, you would need to make sure that you used your parentheses there to make sure that that worked. So this part gives us a negative, and then we still have an I left over. So this would be the simplified version of that. For this one here, this is equal to just plain old -1 all by itself. Here we need to be careful. We have -1. Actually, let me go ahead and do this the long way. I have I squared to the 8th power, which is -1 to the 8th power, which is even, so that's a +1 in there. But remember, I still have the -1 out there. So let's go ahead and change colors so you can see what I'm talking about here for the next one. I again have an I squared. I have 2 sets of those with one left over. So this also would be even, so that would be a positive. But I also had a negative out there, so -I. And then let's look at one more color here. So this one here would be I squared. I have 10 of those with one left over, which means an even number of negatives, which is positive. So this is what I really have. This here would give me -2, whereas this one here cancels out. So that would be my answer, which means my answer ultimately would be real, even after all of that imaginary stuff is going on. All right, let's go ahead and look at this one here. We're doing division, and the goal about division is to ultimately divide this into that. So we have a little trick. We multiply by the conjugate. The conjugate is everything the same, but a different sign in between there. And that makes it work out so nice and real when we're done on the bottom. So this gives me 25, and then we have plus 10i and minus 10i, which is awesome because now there's no more i's. And then I have -4 times I squared, but I squared is really equal to -1, so that's super awesome. So my denominator now is 29 because I have 4 plus 25. And then on the numerator, I have 10 plus 4i when I distribute that too. So you could either write it like this, or you could write it like this. This one is in the complex number format where this is real and this is complex. This is just kind of a little less writing to do by putting the same denominator on the bottom. Our last one that we're looking at here is multiplication. So I do need to make sure that I'm multiplying everything correctly. Feel free to put it into a box where you have your 3 minus 4i and your 2 plus I. Either way is fine. This would give me 6, -8i, 3i, and -4 times a -1, which is really +4. So all of this stuff would be 6 plus 4 would be 10. And then combining those, I would get a -5i. So that would be my final answer for that.